I wanted to go over some problems now from the 10th edition of the book. Let's start with number 3 right here. So this is a limit as x approaches infinity. So since I'm doing a limit as x approaches infinity, I need to divide through by the highest power of x in the denominator. So the highest power of x in the denominator is an x cubed. And so I'll divide everything by an x cubed and do the same thing on the top. And so pretty much everything goes off to 0. Except for here you have the ratio of the coefficients, which is simply 1/3. So that is the answer there. Please remember that we only divide through by the highest power of x in the denominator when we're doing a limit as x approaches positive or negative infinity. The next problem, number 4, is a u sub, so the integral from 0 to 1 of e to the negative 2x dx. How do you know it's a u sub? Well, if you were taking the derivative of e to the negative 2x, then that would have been a chain rule type problem where the negative 2x was the baby. So if we're going to do an antiderivative, then we need a u sub. So our u is going to be that negative 2x. Our du is going to be negative 2 dx. I only see a dx here, not a negative 2 dx, so I'm going to divide through by that negative 2. So negative a half du is what I'm going to replace my dx with. Integral e to the u, and then my dx is replaced with this negative 1/2 du. However, these bounds right here are x bounds, so I need to change them now to u bounds since everything is in terms of u. So if my x was equal to 0, then my u is negative 2x, so negative 2 times 0 is still 0. If my x was 1, then my u is negative 2 times 1, which is now negative 2. So my new bounds are going to be from 0 to negative 2, and I know that negative 2 is less than 0, but you need to put them in the same order that they were. My next step is going to be, I'm going to take this negative 1/2 outside, and I have the integral from 0 to negative 2 e to the u du. Two things you could do. You can flip this if you want the negative 2 to be on the bottom, and then that would make this into a positive 1/2, because remember that the integral from a to b of f of x dx is equal to negative integral from b to a. So if I flip those bounds, then I just take the negative. So that would be the reasoning for doing this, and now I'm going to change my bounds negative 2 to 0, e to the u du. Now I'm just going to take that antiderivative. The antiderivative of e to the u is simply e to the u from negative 2 to 0, and now I can evaluate 1/2 e to the 0 minus e to the negative 2. E to the 0 is 1, so I have 1/2 1 minus, and e to the negative 2 is 1 over e squared. And so that's equivalent to 1/2 minus 1 over 2 e squared. So that answer is simply B. The next question I'm going to do is number 7. The acceleration of a particle from 0 to 8 seconds is given by this table. So this is the acceleration. If the velocity at t equals 0 is 4, so velocity at 0 is 4, the approximated value of the velocity in feet per second at t equals 8, computed using Riemann sum with 4 subintervals, is what? So basically, I'm trying to find v of 8. Now, you might be wondering to yourself, am I supposed to use left Riemann sums, right Riemann sum, midpoints? What am I supposed to use? Well, notice here that we have perfect symmetry, and because of that, it doesn't matter if we use left or right, and so that's why they didn't specify it in this problem. If it made a difference, they would have specified it. So I'm going to go ahead and just use left. So there are my 4, and I'm going to use left 1, 2, 3, and 4. My left Riemann sum with the 4 subintervals is going to be, the width is 2 times the height. First height is 2. The width again is 2, and now the height is 3. I have another width of 2, and now my height is 4. And then my last width is 2 also, and my height is 3. And so I really could have factored out that width of 2, and then I have 2 plus 3 plus 4 plus 3. That's 2 times 12. That equals 24. Now, I have to think. What does this represent? The Riemann sum is representing the area under the curve from 0 to 8 of a of t dt. It is the area under the acceleration curve from 0 to 8. It's approximating the area under that, right? We're approximating it with the left Riemann sum in this case. And so what does that actually evaluate to? Well, the antiderivative of acceleration brings us to velocity, and we're evaluating that from 0 to 8. So that is technically v of 8 minus v of 0. So when we want to solve for v of 8 is equal to v of 0 plus the integral from 0 to 8 of a of t dt. You don't need to prove that every time. You need to know that you need to start wherever, and the bounds are going to be from your starting to your final. And usually your final is what you're trying to find in this case, and usually your starting is what's given to you. If it was the other way around, you could do the same thing, just reverse the process, okay? But you really need to remember, don't get tricked, that you need to add the 4 to the 24 to come up with the final answer of 28. Technically, this is in feet per second right now because this is a velocity type thing, okay? So make sure that you don't forget to add in that initial condition or wherever you started from. In this case, it was starting from 0. The next question that I wanted to go over was number 10. So this is really something that you need to memorize. You need to know that the antiderivative of tan x dx is ln, absolute value of secant x plus c. You need to memorize that one for the AP exam. It is one of the ones that you are expected to know. Okay, so now we can do the problem. They say an antiderivative of 2 tan x for an x in the first quadrant. Okay, so we're just doing the antiderivative of 2 tan x dx, and I'm going to go ahead and pull out that 2 since it's a constant. And now I know that the antiderivative of tan x is ln secant x, ln absolute value secant x, plus c. And that's not an answer choice here. So what I do know is I'm going to use my ln rule right here. So remember that ln x to the n power is n ln x. So I'm going to kind of reverse that rule. So in this case, my n is my 2. And so I'm going to say that's ln absolute value of secant x squared, okay? And since I'm squaring an absolute value, I don't have to worry about the absolute value anymore. So I pretty much have ln secant x squared plus c. And I do see that answer right here as answer choice B. That's one possible solution where my C is 0. Remember that secant x squared is the same thing as secant squared x. And so that's my answer. Number 12 here, they're asking us to find h prime of 3 when h of x is f times g. So that's just a product rule. So h prime is going to be the derivative of the first times the second plus the first times the derivative of the second. And I'm evaluating this at 3. So h prime of 3 is going to be f prime of 3 times g of 3 plus f of 3 times g prime of 3. What is f prime of 3? F prime of 3 means at 3 on the f curve, what is the slope? So the slope is down 1 over 1, 2, 3. So the slope is going to be negative 1/3. And then g of 3 on the g curve, I'm at 3. So that's just 3. Plus f of 3 is simply 1. And then g prime of 3 means on the g curve at x equals 3, what's the slope? So I'm going up 1, 2 over 1, 2. So the slope is 1. So basically I have negative 1 plus 1 or 0. So C is my final answer. So number 19 here, it says dy dx is y over x squared, where y1 is 1, so that's my initial condition, and they want to know what is the value of y when x equals negative 1. So I first need to figure out what y is, so I'm going to do that by separating the variables, right, because they give me dy dx, and I want to find a particular solution. So I'm going to scoot that y over by dividing by y, and then I have 1 over x squared dx. Oops, I forgot my dy. So I have 1 over y dy equals 1 over x squared dx. Now the antiderivative of 1 over y is ln absolute value of y. The antiderivative of 1 over x squared, please do not get confused. 1 over x squared is x to the negative 2, right? And so you're going to add 1 and divide by what you added. Okay, so do not do ln absolute value of x squared. That's a big no-no. So before I solve, I'm going to just go ahead and figure out what that c is. So I know that y of 1 equals 1, which means that ln absolute value of 1 equals negative 1 to the negative 1 plus c. ln of 1 is 0 because e to the 0 power is 1, right? And then I have negative 1 to the negative 1 power is just negative 1 plus c. Therefore, c equals 1. So that leaves me with ln absolute value of y equals negative x to the negative 1 is negative 1 over x. I'm going to just rewrite it like that, plus c, which is 1. Now, in order to solve, I'm going to base e both sides. Absolute value of y equals e to the negative 1 over x plus 1. And then basically they wanted me to figure out when x equals 1, what is y. So I'm going to go ahead. At x equals negative 1, we have absolute value of y equals e to the negative 1 over negative 1 plus 1, which is pretty much e to the 1 plus 1, which is e squared. So my answer is going to be D. In number 21, they have the position function drawn, and it says which of the points marked is closest to the point where the acceleration first becomes negative. So acceleration negative. Remember that we know that acceleration is the second derivative of the position function. And so acceleration being negative is synonymous with the position being concave down. And so it becomes concave down, the position function, right there at point C. So my answer is C. In this problem, they tell us what dy dx is, and they want us to find the second derivative. You need to know that that is notation for the second derivative. And this is x squared times y squared, so I need a product rule. The derivative of x squared, the derivative of the first, 2x times the second, y squared, plus the first, x squared, times the derivative of the second. And the derivative of y squared, this is implicit differentiation. Every y has a baby. So the derivative is 2y to the first times y prime. Okay, but we can't have a dy dx in our final answer. None of our answer choices have that. So I'm going to replace the dy dx with what I know dy dx is. So I have 2xy squared plus 2x squared y times x squared y squared. In other words, 2xy squared plus 2x to the fourth y cubed. And so my final answer is going to be A, because that's that same answer. 31, they're asking us to compare the values of f of 2, f prime of 2, and f double prime of 2, and they tell you that f of 1 is equal to 0. So this is f prime. So I know that f prime of 2 is 0. So f prime of 2 is 0. I know that its derivative is positive, so I know f double prime of 2 is greater than 0. And now, what do I know about f of 2? Think of this. We know that f prime is going from negative to positive, so f prime goes from negative to positive at x equals 2. So it goes from negative to positive. So that means, therefore, f has a local min at x equals 2. So if it has a local min at x equals 2, and I know that f of 1 is 0, then I know that f of 2, it has to be even less than that 0. So that's my clue there, that I know that it's less than 0, again, because it's a local min, so it must obviously be less at 2 than it was at x equals 1. And so it must be less than 0 there. So I know my order is going to be f of 2, then f prime of 2, then f double prime of 2. So my answer is B. 36, they tell us that we have this sketch, and one side of the graph of that If x is measured in feet, what is the projected area? So you should know that the square root of 64 minus x squared is the top half of a circle with a radius of 8, right? And then I'm just doing 4 times that. So that's just a vertical stretch of 4, but that doesn't change our x bounds. We're still going from -8 to 8 on the x-axis. And if you don't know that, you can kind of prove that to yourself. Just find the x-intercepts by setting y equal to 0, and then, divide both sides by 4 and solve for x. 64 equals x squared. X is going to be equal to plus or minus 8. So those are our x bounds, and we want to find the area under that curve. So the integral from -8 to 8 of 4 root 64 minus x squared dx. Just use fn int on our calculator, which is under math 9, and you should get approximately 402.123. They asked us to round it to the nearest square foot, so we'll have 402 square feet is our final answer, C. So in this next problem here, they're asking us to approximate f prime of 4, and they give us this table of our x of x values. And so let me just kind of break it down on the side over here. Say you have these data points, okay? And say you want to find the derivative right here at this point 4. And you could find the slope between those 2 points, one to the left, and you can find the slope between these 2 points, one to the right. And then to find the actual slope, f prime of 4, you would kind of average that green slope and the yellow slope. So to find f prime of 4, I want to do that same type of thing. I want to average with a point right to the left and average with a point right to the right. So let's find the slope between 3.999 and 4, and then we'll find the slope between 4 and 4.001, and then we're going to average them. So the slope between 3.999 and 4, we would do f of 4 minus f of 3.999 all over 4 minus 3.999. If we put that in our calculator, we're going to get 2.34. And then we'll do the same thing with a point to the right. So find the slope between 4 and 4.001. And we put that in our calculator. And we're actually going to find 2.34 also. So this is symmetric right there. But what you do is just average those two. And obviously the average between 2.34 and 2.34 is just 2.34. And so that's our final answer to this question, D. So in this next problem, we need to recognize this as an integral because we're doing the limit as n approaches infinity, and that 1 over n is our delta x, that's our width, and so that's just our dx part. And then let's think about what our bounds are. And we're starting at this 1 plus delta x. So that is going to be, we're starting at 1, and then we're going to 1 plus n over n, and n over n is 1. So 1 plus 1 is 2. So those are our bounds. And then what are we doing? We're doing this 1 over 1 plus delta x. So what's our integrand, what's in between, is just 1 over x. And that's really it. So again, you know that our 1 over n is our delta x, and we're doing 1 over 1 plus delta x. So 1 plus delta x means that we should be starting at 1. That's our starting point. And then 1 plus n over n is 1. 1 plus 1 is 2. So that's our ending point, 1 to 2. And then we're just doing 1 over that 1 plus delta x. So B, that's our final answer. Now in this problem, 43, they tell us that f prime equals cosine x over ln x plus 1, and they're asking us on this interval from 2 to 10, what do we know? So let's go ahead and graph this. So in y1, go ahead and graph cosine x over ln x plus 1, and make sure that you're in radian mode. Be in radian mode for the whole AP exam. And here's kind of the graph. It's messy, excuse that. But anyway, this is what I put in y1, and I just graphed it, but this is our f prime function. And so A says f is always increasing or always decreasing. Well, we know that's false because we have both negative and positive regions on f prime, meaning that f is decreasing and F is increasing. So that's false. Now let's look at B. F has a relative minimum, not at an end point. If we look at our F prime graph, a little past 4, we see that it's changing from negative to positive. So it's changing from negative to positive once on this interval. So we know we have a relative min somewhere there. So that is actually true. We know that. And then 3 says f of x has 3 points of inflection. Well, a point of inflection happens when f double prime changes sign. And f double prime changing sign is the same thing as f prime changing from increasing to decreasing or decreasing to increasing. And so let's see how many times that happens. So let's look at our f prime curve, and we see that it's decreasing on this region, and then it's increasing on this region, and then it's decreasing again on this region, and then it's increasing again. So from 2 to 10, we see that it changes from decreasing to increasing, increasing to decreasing, then decreasing to increasing. So that happened 3 times. So yes, that one is true. So C is our answer. And that's it. I hope this helps.